All right, so today we're talking about radians for the first time. You haven't learned what radians are before, but a radian is what you just drew right there. That angle where this distance and this distance were the same, we made 7 M&Ms in both directions, right? If those two are the same, then of course this radius coming back has to be, by definition of a circle, the same as this. And if all three of them are the same, then that angle you have right here, how many degrees would you say that is? It's about 60, but it's not 60. It's exactly 1 radian, which is actually a little less than 60. I know it's annoyingly close to 60, and it seems like it's 60, but I'm going to prove it to you that it's not 60. If it really was 60, if I put 3 of them side by side, that it would hit perfectly down here at 180 degrees. I'd like you to do another set of 7 and another set of 7. Just use the same M&Ms, keep moving them over. And I want you to see that it does not hit exactly. It's important for you to get. Everybody thinks a radian is 60 degrees. It is not. A radian is close to 60, but short, and it's exactly short a certain amount, which I'm going to make you try to figure out. And maybe you'll figure out why it doesn't quite make it. Okay. Do you get that it's a little bit short? Give me an opinion on this now. People have different opinions. I don't expect this to be perfect. Do you think it's like 1 M&M? Maybe 2? I don't know. Was it more than 1?
I say 1. Well, it's mine, because I don't think I do. Maybe like 2.5. Mine's not. Wow. That's a huge margin. It's okay.
Who has either 1 or less than 1? Right? Who has either 1 or a little more than 1? All right, so then that's on average about 1 M&M short. Okay, so what's the point? The point is a radian is one of these. It's about 60, but it's a little less than 60. If it had been 60, it would have hit perfectly, right? So it's 3 point something radians equals up to 180 degrees. Think about it. What do you think? 3.14, also known as pi. What you just found there is exactly what 3.14 looks like if you did it exactly, and if your M&Ms were perfect, and if everything was perfect. Then what you got there is exactly 3.14. That's the 0.14 part. 0.14 of a radian, like 14% of a radian. All right, because 3.14 is pi, right? And we're working with circles, right? And 180 degrees is here, right? If you open it all the way up, that's a 180 degree angle. 180 degrees goes with pi. They are synonymous. Why? Well, it just has to do with radians and how they're designed in the first place. Radians weren't supposed to be a certain number of degrees. Radians were set up so that it would work out really nice, that when it went around 180, that would be exactly pi. And actually, they weren't set up because of that, but it works out that way. And then think about it. If it goes all the way around the circle, will be 360 degrees, and that's 2 pi. Very good. Okay, so if this is 0 degrees is where it starts, and it's also 360 because it's where it ends, 360 is the same as 2 pi. And 180 was the same as pi. All right, so let's say I had a wedge of a circle. And this is just part of a circle, right? Okay, then let's say that this is 8 inches long, and this is 2 inches long. We can figure out how big this angle is right here if we use radians. S equals theta r is our new formula for the day. You might want to write that one down. Write this on top of your circle page, or wherever you want to write it. S equals theta r. And above S, put arc. Do you get that this is the arc? The curving line there? that curving line will be equal to the radians. That's theta is radians. It's not in degrees, it's in radians. Times the r. Take a wild guess what the r stands for in this picture. The radius. I know that's confusing. One's in radians, and we're multiplying by the radius. All right, in this case, S is 2 equals theta. I don't know how many radians it is. I put theta. It's just a placeholder variable. And what is the radius? And then if I divide by 8 on both sides, do you get how I'm going to have 2/8, which is the same as what? 1/4. Theta is 1/4. What the heck does that mean? It's 1/4 of a radian. And I know a lot of people would like to know exactly what that number is in degrees. If you wanted to, you could. But you have to know the conversion between degrees and radians. What was it again? 180 goes with pi. Okay. So then if this is in radians, just wait. I'm going to take 1/4 and I can multiply it by a fact which is true. The fact which is true is that there is 180 degrees with pi radians. And now I have just changed this into the exact number of degrees it would be. And so I'd take 180 and divide by 4 times pi, and that would give you exactly how many degrees it is. All right, I know that was a little confusing. Let me break this down into simpler little parts. Okay, so here's the circle. Here's a wedge of the circle. If this is 10, and this angle right here is exactly pi radians. Can it be pi radians? No, pi's over here. So do you get that's got to be some fraction of pi radians? I'm going to say that this angle right there, I'm going to keep it really simple for you guys. For right now, I think let's do degrees because they'll understand it a lot better. Okay, so if it's 10 inches, and that's a 45-degree angle, well, then this has to be 10 inches, right? And what's that? Use S equals theta r. But the problem is, you won't be able to do it until you change this into radians. I just showed you how you multiply by either 180 over pi or pi over 180. See if you can do it right now on the back side of your worksheet that you've got. Solve. Remember, the theta has to be in radians. So you're going to have to change that 45 degrees to radians. Otherwise, this won't work. No calculators. You need to be giving exact answers. I'll pause for a second while you give that a try. All right, let's see if you got the right idea here. S, I don't know. Theta, ooh, that's the 45, isn't it? But no. Why can't I just put in 45? Because this formula is built for radians. So then I got to change it to radians. What was that little factor again? Pi over 180 or 180 over pi? Which goes on top? Pi over 180. Why? Because you want the degrees to cancel. Unless you want degrees in your answer. That wouldn't make any sense, right? So we want those to cancel. So there we go. 45 pi times the radius, which is 10. And so once it's all set, smoke all settles here, 45 times 450 pi. That's the answer. 450 times 3.14. I'm sorry, you're right. That was the degrees canceling, all divided by 180. Good. Thank you. I was actually looking at it desperately going, why is it too big? Why is it too big? Why is it too big? Because I was thinking this is way too big of an answer. That makes sense now. Sorry, I dropped my 180. I thought it was like a 100 and I was somehow dropping it. Okay. Let me give you another one that's even simpler. Change this to radians. It's close to 1 radian. Remember me saying it's close to 60 degrees? But it's not exactly 1 radian. So what do you multiply by? Pi over 180. Yep. Degrees cancel degrees, zeros cancel 0. 6 over 18 reduces to, well, if you can factor, it should. I'm going to change this 18 to 6 times 3. And that way my 6's can cancel also. It's pi over 3. Now think about what that means. What is pi? 3.14. Do you get how 3.14 divided by 3 is really close to 1? But it's not 1. 3.14 is what pi is. So it's close to 1. Shouldn't 60 degrees close to 1 radian? Yeah, they're close. Okay, I'm going to ask you. Radius is what? 8 inches. And what? Well, this side is 2 inches. All right, so in that problem, what we did is we go S equals theta R, and S is 2. Theta, we don't know. R is 8. Get what to do now? Divide by 8 on both sides. 2/8 is theta. Theta is 1/4. 1/4 of a radian. And since radians are about 60 degrees, about, and they're not equal to that, but they're close, it's about 1/4 of 60 degrees, which is about 15 degrees. If you wanted to know exactly how many degrees, you'd multiply by 180 over pi or pi over 180. And this one's in radians, so we want the degrees to stick around. There we go. 1/4 of 180, all divided by pi. And that comes out to about 15 degrees. Okay, so you have a formula you've learned, S equals theta R. It only works in radians, and you're still just kind of sketchy on what a radian is. Do you get that we did this activity because if you have this is 10 and this is 10 and this arc length is 10, how big is this angle right there? About 60, which is a radian. If this is the same as this, then you've got a radian. And how many of those do you get on the top half of a circle? 3 plus a little bit more. Exactly how many? 3.14 of those would go on the top of a circle. And you'd have this little leftover part here. Why? Because you really need 3.14. And now you should be relating 180 degrees with pi. And they go together like a fact. 180 degrees is pi radians. So if you have facts, you would learn this like in your chemistry class. If you have 60 seconds in 1 minute, you can put them in a little factor like this, right? It's just you're multiplying by a fact. If they're really equal to each other, you're multiplying by 1. That's why you can do that. So if these are really equal to each other, we can multiply by 180 over pi or by pi over 180. And it won't change our value at all. It'll be multiplying by 1, basically. It's just that you'll change it from degrees to radians, or from radians to degrees. All right, so 90 degrees. How many radians is that? Figure it out. Yes, sir?
So pi has a unit of radians, right?
Yes, but radians have no unit.
Yeah, they just are.
I know that's weird, but I'll show you why they can't have units by doing another one of those problems in a second here. So real quick, what did I multiply by? Pi over 180. Degrees cancel, a 0 cancels, it's 9 over 18. That pretty much means it's pi over 2. Half of a pi. Does that make sense from where 90 degrees is? It's halfway out there, right?
Yeah.
Half of pi. It's pi over 2, so it's about 3.14 divided by 2. So it's about 3 divided by 2. So it's about 1.5 radians. All right, next thing. If 180 and pi go together, then what does 360 go with? 2 pi. Does that make sense to you? If this is 180, and it's the same as pi radians, 3.14 of those radians, then getting to 360, which is going all the way around the rest of the way, means that you just went 2 pi. And 360 goes with 2 pi. But we don't ever do this because it would just reduce down to what? 180 over pi. Or you could flip it and say pi over 180. All right. Now, last thing I got to do is teach you area of parts of a circle. Let's say that the area of this circle was 100, and I gave you 10% of the circle. Do you get that this wedge area would have to be 10% of the 100, which would be what? 10. What if I gave you a circle that had an area of 100, and then we do half of the circle? Well, duh, what's the area got to be? 50. It's half of it, right? So we're pretty much just taking a part of the whole area. So if the whole area is pi r squared, who can tell me something smart about how to tell the area of a wedge of that circle, a sector of a circle? It's got to be a part of it, right? What if it was in degrees? What if this was like 30 degrees? So give me the whole numbers before you reduced it. 30 over, no. 30 over 360. That would be the area of the circle. Does that make sense to you? It's this part of the whole. What if I do the whole circle? Then it's 360 out of 360, right? And then if this is 360 over 360, it's just the area of the circle, which makes sense. So when you have it in radians, here's my wedge now. And let's say that this is 5. My area of my sector, you want to write this down, is theta over 2 pi. Do you get how that's kind of like taking it out of 360? Because 2 pi is like 360. It's just in radians now. And then what's this part? Still pi r squared. This is the fraction of, and this is the whole circle. What fraction of my circle do I have? Well, this right here is theta. And if it was the whole circle, theta would be 2 pi. And then it'd be 2 pi over 2 pi, which would mean the area of the circle is just pi r squared. So to answer this question, if I gave you this problem, I said that was 5 inches, and I said this angle right there is pi over 3. Try to stick the numbers in the formula and get the answer for me. That's the last kind of problem that's on today's homework. Here's the formula you're using. Get some stuff to cancel. The area of the sector would be pi over 3 over 2 pi times pi, and then what's r in this case? And then what's r squared in this case? Now, can I get some canceling to happen? Absolutely. I'm going to choose to cancel this pi and that pi. Why not those two? Then what I'm left with is pi over 3 over 2 of or times 25. And I have 1 pi left in my answer. Now you could do another, but you're going to still have to do the flip and multiply like I'm going to have to do in a second here. I'm going to put this over 1, and now I'll have pi over 3 times, flip it, 1/2 times 2 pi. Wait a minute. Yes, there's a 25 in there. Sorry. You're right. Sorry. Those canceled. This 25 came down here. Yep. I'm going to try that again. Here. I'm just going to start from there. Pi over 3 over 2 times 25. And that becomes pi over 3 over 1. no, not 1/2. 2 over 1 times 25. And that becomes pi over 3 times 1 over 2 times 25. And that becomes 25 pi over 6. And there's your answer. Okay, now listen close. The first 2 pages of your assignment today are about converting things like this degrees, minutes, seconds. That can be done with a calculator and then this little function called DMS. I will show you that a different day. What that means is I don't need you to do the first 2 pages of the assignment. I want you to focus on the things we just did, which is use those 2 formulas. So you may skip the first 2 pages of day 1. And I believe the first problem that you're going to do is called number 37. All I can tell you for sure is you skip the first 2 pages of day 1 assignment. Okay? And then you'll use these 2 formulas a lot. S equals theta r. And area of a sector is pi over 2, or sorry, theta over 2 pi times pi r squared. And the last one is you need to know how to change 180 over pi or pi over 180. You can reverse these two to change from degrees to radians or radians to degrees. Okay, it's really not too tough of an assignment. Skip the first 2 pages of it. That's all I got for you for today. Have a good day.